In this video, we'll discuss solving the system of equations with three variables. Our basic strategy is going to involve eliminating a variable using equation 1 and equation 2, and then eliminating that same variable using equation 2 and equation 3. So in this problem, I'm going to choose to eliminate x. Alright, so you need to have, to continue, you need to have some background with solving with elimination, solving by elimination. So let's look at equation 2. Now, if I multiply equation 2 by 2, I'm going to get matching coefficients of 4. So take a look at this 2 here. This 2 would be a 4 if equation 2 was multiplied by 2. So I'm going to outline my basic approach here. I'm going to take equation 2 and I'm going to multiply it by 2. After I multiply equation 2 by 2, I'll be able to do equation 1 minus 2 times equation 2 to eliminate the x. Let's see how that looks written out. This is going to be 4x plus 2y plus 3z is equal to 1. And now 2 times equation 2 is 4x minus 6y plus 10z is equal to negative 28. Now we'll subtract the two equations. 2 minus, you can see that the x's cancel out. 2 minus a negative 6 is a positive 8y. 3 minus 10 gives me negative 7z. And 1 minus a negative 28 is 29. So now let's follow the same strategy. Let's eliminate x using equation 2 and equation 3. Now notice if I take equation 2 and I have a coefficient of 2 out here, if I multiply it by 3, I'll get matching coefficients with equation 3 where they would both be 6. So I'm going to outline that strategy here. If I take equation 2 and I multiply it by 3, I'll then be able to subtract. Let's see how that looks. 3 times equation 2 gives me 6x minus 9y plus 15z is equal to negative 42. Okay, so I tripled everything, and now equation 3 looks like this. 6x minus y plus 4z is equal to negative 1. Now I'll subtract the two equations. Uh, 6x minus 6x, there's a cancellation like we talked about. A negative 9 minus a negative 1y, that gives me negative 8y. 15 and 4, 15 minus 4 is plus 11z. Negative 42 minus a negative 1 is negative 41. Now notice this gives me a new system with two equations and one unknowns where this is my first equation and this is the second equation. Now we've got to solve that system. When that system is solved, we'll have values for y and z. So let's do that over here. We've got the first equation in the system is 8y minus 7z is equal to 29. Second one is negative 8y plus 11z is equal to negative 41. We'll add the two. The y's eliminate. And negative 7 plus 11 gives me 4z. And 29 plus negative 41 is negative 12. Divide both sides of the equation by 4. And z is equal to -3. Now I'll use the fact that z is -3, and I'll plug it right in here, and I'll be able to solve for y. So let me continue that over here. I know that 8y minus 7 times -3 is equal to 29. So this says 8y plus 21 is equal to 29. Subtract 21 from both sides. Okay, so this says 8y is equal to 8, which tells us that y is equal to 1. Now we've got values for z and y, and if you relook at that first equation, or any of these equations, as a matter of fact, we can choose whether we want to plug in for equation 1, equation 2, or equation 3. So I'm going to choose equation y. 4x plus 2y plus 3z is equal to 1. And I'm going to plug the values that we got here and solve back for x. So let's do this right here. We've got 4x plus 2y plus 3z is equal to 1. We don't know what x is yet, but we do know that y is 1. So we got 4x plus 2 times 1 plus 3 times -3. That's the z value, is equal to 1. We know that 4x plus 2 minus 9 is equal to 1. Combine the like terms. 4x minus 7 is equal to 1. Add 7. We know that now that 4x is equal to 8. And therefore x is equal to 2. So our solution is 2, 1, -3.